Hey friends, we're still in chapter 3 and we're checking out direct variation. So we have a couple of vocabulary words here that I'd like you to keep in mind, and they're really easy. Direct variation refers to a really specific type of equation, one that looks like this. If you have y equals to k times x, you've got a direct variation equation where y is a variable and x is a variable, but k is not a variable. K is some kind of constant. And that brings us to the next two vocabulary words, which is constant of variation or constant of proportionality. Both of them refer to K. All right. So if I had, let's say, the equation y is equal to 3x, then in this case, this is certainly a direct variation equation. And the reason why it's direct variation because it fits this form. And furthermore, 3 is referred to as the constant of variation or the constant of proportionality. This is a type of equation that you will see that's really, really common. Think about if you go to the store and you buy, 25 pairs of jeans or something like that, and each pair of jeans is $15 because that's how I like to buy mine. Don't laugh, people. So the amount of money that I pay, I'm going to call it P, is equal to 15 times J, right? And so J is obviously the number of jeans that did I say? Yeah, well, J is the number of jeans. $15 is the amount of money that I paid for each pair of jeans, and P is the price that I paid. So 15 in this case, again, is going to be my constant of proportionality. And notice that P and J vary directly or have direct variation. All right, so it's kind of a big word for a concept that you guys are really comfortable with. Let's look at some examples. If we look at these two lines and their equation, the respective equations, we can find out some really interesting information in reference to the slope and the constant of variation. So if we were to look for the constant of variation, remember it's the K value. In this equation, we could see that the constant of variation is -2, right? And then if we come over to the line that is the physical representation of this equation, we'll see that the slope is -2. So I don't think that this is really earth-shattering to anybody, but the reality is the constant of variation is the same as the slope. We can see the same thing over here. The constant of variation given the equation is 1/2, meaning that's the K value. But then if you look at this, our rise over run, if I go up 2 and over 4, that's what I tried to indicate here, up 2 and over 4, that's 2 over 4, our slope again is 1/2. So I'm getting the slope by looking at the picture, but I'm getting the constant of variation by looking at the equation, and we can see that both are the same. This is, and I mentioned that this shouldn't be earth-shattering because reality is you guys know this form somewhere in the back of your mind. This is lurking, y equals mx plus b, where m is the slope. You guys are used to that. We've talked about that extensively last year. But this b piece is the y-intercept, right? I'm about to blow your mind, is the y-intercept. You don't have to write this part down. We're just chit-chatting a little bit. So if the y-intercept is b, what do you notice about these little direct variation equations? Right? What do you notice about them? None of them really have a b. Or, I shouldn't say that. If they do have a b value, what's the b value? +0. So technically the y-intercept is 0. Notice that every time we do these direct variation equations, they always pass through the origin because the y-intercept, wait for it, is 0. I know you're probably not that impressed. Let's look at another example. Okay, so we are graphing a direct variation equation, and so here we've got y is equal to -6x. You know what? I kind of let the cat out of the bag in the last example. The fact is, it's direct variation. There's no y-intercept. I know we haven't officially talked about that this year, but you get what I'm saying. Not that there's no y-intercept, but the y-intercept is 0. So all direct variation equations go through the origin. So I know that's the first point I have. And then I can rock out with the slope concept. I know that slope in this case is -6, which is also my constant of variation. I can write -6 as 6 over -1 or -6 over 1. I choose whichever, they're both equal. I choose whichever one is more appropriate for the positioning of my graph. So if I were to look at this first one, I'd have to start here, rise 6, and then move back to the left 1. And that works fine. So I start here 1, 2, 3, 4, 5, 6, back 1. Here's my other point. And now I can draw a line through that. Let's say that I had more space down here on my graph. I could use this version of -6 and go down 6, 1, 2, 3, 4, 5, 6, and go to the right 1. Anyhow you take it, either way you look at it, the slope will lead us to the same line. And that line looks something like this. So when we graph a direct variation, remember that the line always goes through the origin. Okay, so here's our third example. We're going to write and solve a direct variation equation. Sorry for the sloppiness here, but I think you guys can read with me. It says, suppose y varies directly as x, and when y is equal to 72, and y equals 72 when x equals 8, find x when y is 63. Well, what we need to do is take the first sentence and really establish a relationship between y and x. The fact that we've got this varies directly means we're dealing with direct variation, okay? So when the text, when you see varies directly, know that that means direct variation, and automatically you can say y is equal to some k value times x. The next thing you want to do is, before we even go on to this last portion here, right? Before we even touch this last part that I have double underlined, what you want to do is figure out what this equation is. What is the direct variation equation? And to do that, I need to plug in the givens. So the given here is y is equal to 72 when x is equal to 8. So I'm going to plug that in. 72 is equal to k times 8. Notice I merely replaced the given values of 72 and 8 with y and x respectively. All right, so now I think it's pretty clear. You can see, I think most of you can see, that I can divide both sides by 8, swoop delicious, and k is equal to 9. So my direct variation equation, my general equation for this relationship is y is equal to 9 times x, right? So now that I have this standard relationship, now I can get to this last triple underlined section where it says find x when y is 63. Simple. Plug 63 in for y, set that equal to 9 times x, and go about my business of solving this equation as I normally would. And what I find out is that x is equal to 7. So that the answer to this problem is 7. I want to go back over really quick. There were two things we had to do. First, we used the given equation to establish the given information to establish the general direct variation relationship, which became y equals 9x. And then we could find any other information, particularly the value of x when y is 63. All right, good people. So we've come to the end of another delightful lesson, hopefully not too long. Please follow along with the assignment in your packet. It's also written here for your benefit. Let me know if you have any questions tomorrow. Pop quiz? No, maybe. Be ready for one. I'll see you guys tomorrow.